We will solve this problem using the method from section 7.6. An airplane flies 110 degrees for 300 miles, then flies 230 degrees for 400 miles. How far is the airplane then, and in what direction from the starting point? As with any vector problem, I need to first draw a diagram. And you'll notice that I set up navigation references on my axes. From that, I get a reference angle here of 20 degrees, and my distance is 300 miles. My second vector is also from the origin. It's a 230 degree heading. This reference angle is 40 degrees, and I label the length as well. Next, I will draw my parallelogram to help show where the resultant will wind up. And I can draw the resultant vector in. Notice all three tails connect at the origin. After this point, I need to now convert to polar mode. So this diagram was done in nav. Now I need to go to polar and get the direction angle using my standard trig angles. So what I'm thinking here is I now have 0 degrees on the x-axis, 90 degrees up, and 180, 270 as they come around. I'm also going to label the first vector vector A on the right. We'll label the second one vector B. So looking at this angle here, the standard trig angle is all the way around, we'll say theta 1, and it's 340 degrees. And this angle from standard position is, we'll call it theta 2, is 220 degrees. So essentially what I have in polar form, vector A, there's r, and there's theta, and vector B, there's r, and there's theta. Now we know we cannot add the polar forms, so we have to write these in rectangular form to be able to add them. So I just set up my vectors over here, and the x component for vector A, 300 cosine of 340 degrees, and the y component 300 sine of 340 degrees. And then vector B is 400 cosine of its angle, 220, and 400 sine of its angle, also 220. Now I can add these, and what I need to do is just take the two x components and add those, and if you put those in your calculator, you will get negative 24.50999. Then we take the two y components, add those together, and get negative 359.72109. At this point, you can consider this to be almost a new problem. And now I'm going to start with a new diagram. And this is a reminder that this resultant vector is in quadrant 3. Now I use the distance formula to find the length of our resultant. And when you put that in your calculator, we get 360.6 miles. The next thing I will find is the angle theta for vector r. So it's the inverse tangent of y over x, which is the inverse tangent of the negative 359 over the negative 24. And when you put that in your calculator, you get 86 degrees. Well, back on our picture that we drew for ourselves, 86 degrees is actually in quadrant 1, so we know that's the incorrect angle. So I add 180 degrees and I get 266 degrees. That's still not my final answer because that is actually polar, and I need to go back to navigation. So on my diagram, if this is 266, then this angle here is 4 degrees. And from a navigation reference, which I'll label here, down here is 180. So what that means is my final heading is the 180 plus the 4, and so the heading is 184 degrees, and the length of my resultant is 360.6.